Welcome back, Math 2. Okay, no examples really today. Today we're just going to talk about when to specifically use each different method of factoring. We've got 5 different methods, so there's a lot of options. And I know a lot of you will probably stick to maybe 1 or 2, maybe 3 methods. I'd like you to try to use as many as you can. So on the following homework page, you're going to have 10 problems, and there's 2 for each type of method, and you're going to have to identify which method's going to be the best to solve them. So first off, just going in order of how we learned them, the first one was square roots, so that would be something like when we had x squared minus 2 equals 7, okay? So when to use this method? So remember, all of these start out as ax squared plus bx plus c. Okay. So the best time to use this one is when there is no bx term. Because if there's no bx term, you can get this x squared piece by itself very simply. And our steps to it are just to isolate the x squared term, then square root both sides. Excuse me. That is my favorite one to do. It's usually quick and easy, nice and simple to solve. Okay. The next one we learned was factoring when our a equaled 1. So that might have looked like x squared plus 3x plus 2. Okay. So this one I would use if you have an a equals 1 term, obviously, because that's what it states right here. Also, if you can find factors easily. Okay, because remember, the qualification is that it has to multiply to make your last term, and it has to add to make your middle term. So like I can quickly see, oh, 2 times 1 is 2 and 2 plus 1 is 3. So that's something I can do quickly and easily. Okay. So we want, in our steps for that, we want to split into 2 parentheses with an x in each. And then we want to write that these 2 numbers should add to make b and multiply to make c. Alright, our AC method, where a is bigger than 1. So this is still factoring, but when we have a larger number than 1 for our a term. So again, the qualification is that we do have to have an a larger than 1 to be able to use this method. Again, it's kind of the same idea. Can you find factors easily? So for a quick example, if I had 3x squared plus 8x plus 4, okay? Well, very quickly I can say, okay, 3 times 4 is 12, and just some quick factors of 12, I know 6 and 2 will make this 8. Okay? So, sorry if you need to have more written out in your notes, okay? So that I would know I'd be able to solve with the AC method, because the biggest thing is finding out which method can you use and which ones can't, because you don't want to start trying to do the AC method and spend like 5 or 10 minutes on it and then realize it can't even be solved with the AC method. So it's just a quick check, can I do this quickly? Because sometimes, even if it is possible to use an AC method, by the time you've found a factor, it's not even worth it. You might as well have gone and used the quadratic formula, because that might have been quicker. Okay. So our steps, remember, step 1, we're going to multiply a times c. You're going to find the factors that make b. And then you're going to use that box method. If you do not like the box for factoring with the AC method, please come talk to me. I can show you another way to do it. The box has just made that last part of it so much simpler that that was the only way I chose to show you. But if you are really struggling with the box, you don't like it, please come talk to me. There is another way to do it that I've been doing my whole life until this last year, okay? All right. Completing the square. All right. So this one is good to use whether you have A equals 1 or A does not equal 1. Okay, maybe it's bigger or smaller. It's preferable to use it. I don't think I spelled that right, but whatever. This is an English class. It is preferable to use it when we have A equals 1 as opposed to a larger number. If A is not 1, this is still good to use if all the terms, so A, B, and C, are all divisible by your A term. Okay. So for example, if I had 2x squared plus 8x plus 6, okay, all of those are easily divisible by 2, and I won't have to deal with any fractions. Okay. I would only use this method on A equals 1 if it cannot be factored. Because factoring is much quicker than completing the square. So if you can factor it. But otherwise, you can complete the square on it. Okay. So remember our steps for that. Okay. We want to take our B term and divide it by 2. And then we want to square that number. We add and subtract that number in the equation. Okay. And then we factor the perfect square trinomial. And then we pretty much solve using square roots almost. Again, if you want more examples of completing the square, come talk to me. We've got a whole back page we can use for that. Okay. And our last one, the quadratic formula. Okay, I'm going to write, I'll just write it. Okay, so the quadratic formula is usable on anything, really. So you can use it on any sort of, you could even use it all the way back up here at x squared minus 2 equals 7. Now I wouldn't, because it'd be so much easier to solve this with square roots. Okay? But you want to use this if no other method works. So when no other method works or is not time efficient. Okay. Here's what I mean by time efficient. Remember, I had this example for the AC method that I can quickly see 3 times 4 is 12, and 12 has a combo that will make 8. But I know there were some of your homework problems where you ended up with like a huge number of like 196, and then you're spending a really long time on your calculator trying to figure out what combination of numbers makes this middle number, when you could have, in the same amount of time, probably finished solving with the quadratic formula. So if something looks like it's not going to be able to be solved quickly with one of these other methods, you can go ahead and go straight to the quadratic formula. Okay? And our steps to that, well, we just need to have the quadratic formula. Negative b plus or minus the square root of b squared minus 4ac all over 2a. And our steps are to plug in a, b, and c, and to solve. Okay. So these are all your different methods. This is a great cheat sheet to have to know when to use what method and what's going to be most helpful to you.